Hello, good evening once more. Okay, so uh, you remember the last slide we were talking about um, complementary functions. So these are examples of solving. Sorry about that. Solving particular integral, but with the use of operator d. Do you get? Alright, so the first question we have here is d square y dx square minus 6dy dx plus 9y is equals to x. Recall when I said that d square over dx square is capital D squared and d over dx is capital D. Do you remember? So the very first step I did here was CF. Okay, and remember when I said that all CF are always usually equated to 0. So your answer could be in form of either complex roots, equal roots, or different roots. So now, in place of d square over d x square, we have d square y. Okay, yeah, and in place of d all over dx, we have d. So you make y subject of the formula. So after making y subject of the formula, you divide both sides by the coefficient of y, which is d squared minus 6d plus 9. Now pay attention as I explain this. I know you guys must have had series of questions why there is a negative sign right in front of the 2. Yeah, so let me explain. Now d, as you might know, it can also be termed differentiation. Do you get? Now if you differentiate cos 2x, be it once or twice, if you differentiate it the first time, what do you have? A negative sign, right? Even if you have a sign here, when you differentiate it twice, you still have a negative sign. Why am I really focused on it, on the differential of it being 2 times? Because the highest is d squared. Do you get? So now the very first thing you do, cos 2x all over d square minus 6d plus 9. You don't, wherever you see d, okay, wherever I see d square, you only substitute the d that had a squared sign. Okay, you replace it with 2. How did I get 2? From the cos 2x. If this cos 3x, it will be 3. If it's cos 5x, it will be 5. Do you get? Now I've explained where the negative sign comes from. Into 2 all square. So you do the normal solving, and you end up having cos 2x all over 5 minus 6d. Then you rationalize, multiply both the numerator and the denominator with the, should I say, the inverse of the denominator, which is 5 plus 6d, or should I say opposite here, which is 5 plus 6d, or should I say the prime of the denominator. In there you want to do it. This is math. We are not in English class. So you multiply that, then this is what we have: 25 plus 30d minus 30d minus 36d squared. Now remember when I said you only substitute wherever you see d square. So in place of d square, you put minus into 2 all square. You see it here? So after doing that, we have 169. Then when you expand the numerator, you have 5 cos 2x plus 6d cos 2x. Now this can also be written as 5 cos 2x all over 1 plus 169 plus 6d cos 2x all over 169, because both of them, they share the same denominator, which is 169. Okay, now remember when I said that after solving, at the end of the day, when you have d as the numerator, you differentiate once, right? And when you have d square as numerator, you differentiate twice, right? So now here you have 5 cos 2x over 169. Don't touch it. There's nothing that this guy has done to you. Your main focus is wherever you have the d. Now you have 6d cos 2x, meaning you have to differentiate of the coefficient of the d, which is 6 cos 2x. So when you differentiate 6 cos 2x once, you have minus 12 sine 2x, and that is how I got minus 12 sine 2x. Now observe where the d is located, and on the numerator differentiate 6 cos 2x once. Exactly what I said. Then this is your pi. Then remember the solution, the general solution. CF y is equals to CF plus pi. Now this is for trig functions only, when it is equated to trig functions only. Now what happens if it is for exponential with a trig function? As usual, you find your CF. Our main focus is the pi, and I had explained how the steps here. Now when we are focusing on the exponential, okay, you tackle the exponential first. So wherever I see d, you replace it with plus whatever thing the exponential has. Here you have exponential 3x, so you add 3 to wherever I see d. Do you see? Now I'm using the difference of when we are dealing with exponential and when we are dealing with just trigonometry. When we are dealing with just trigonometrical functions, we are focused on d square, but here wherever you see just any d, just replace it with d plus 3, and you understand where I got the 3 from the exponential function. So after doing that, you expand. When you expand, you have d square left. Now remember when I said that when d square is the denominator, you integrate twice, right? If it's the numerator, you differentiate twice. Have you seen the difference? Now this plus 3 means that you are totally done with dealing with the exponential function. So main focus now will be the sine 2x. So now, because this square is the denominator, that means you should integrate sine 2x how many times? Two times. Okay, I'm using layman English to explain. Once there is exponential function in the equation, tackle it first by adding d with whatever number exponential function is with. That is, exponential 3x will be d plus 3, 2x will be d plus 2, and so on. I'm using layman English. Notice that d square is the denominator. So what are you going to do here? Sorry, let me try and see how I can do it. Oops, sorry for that. Okay, I think I've seen what I wanted. Now we integrate sine 2x twice. I think I made a bit of a mistake here. If we integrate sine 2x all over this, sine 2x alone, you have minus cos 2x over 2, and that's exactly what I did here. Okay, like I said, you don't touch this guy again. Exponential, focus on the trig. When you integrate cos 2x over 2, you have minus sine 2x over 4. It ought to be sine 2x. Please forgive me, just a slight mistake there. So that is that about exponential functions with trig. How about when it is equated to exponential functions with another function entirely? Okay, so first step, you know what to do. Make y sort of the formula, divide both sides by the coefficient of y, and you have this. Now wherever the position of exponential, you focus on exponential first. As far as you've seen exponentials in a particular question, tackle exponential first. After doing that, whatsoever we have, wherever I see exponential is exponential 3, so wherever I have d square, you add it with plus 3, add d with plus 3. After expanding, we have d square, and that means our focus should be on the x. So it means I should integrate exponential 3 2 times. So that will be exponential 3 over 3 and exponential 4 over 12. Sorry, 4. What am I saying? Okay, the very first one is you have exponential. If you integrate exponent in x raised to power 3, you have x raised to power 4 over 4. That means you have integrated the first time. If you integrate again, you have x raised to power 5 over 5 times 4. That's how I got 20. This d meaning that it changed from d squared to d, meaning that you still have to integrate again. Now once you're done integrating, everything goes. You're free. You're free to move on. So that is how it is. Is that easy? Extremely easy. All you just need to do is just to dedicate yourself to reading it. Okay, and I'll be glad if you do so, because the course is actually very okay. Alright, so that is all about this particular topic for now. Now, y is equals exponential 3x into a plus bx. Now, this was a CF of this question, as you can see, and this is a pair of this question. So this is how to go about the operator. Now, another thing you should know, that if a question like this is equated to maybe a constant like 5 or 6, just know that wherever you see d, you replace it with substitute with what? 0. So that is that for today. I hope you understand. Feel free to ask questions where necessary. Okay, so this is it for this particular session.